The Physics of Interstellar Travel, Chapter 17, Outlook. At the beginning of the book, and these videos, I said that we would only focus on existing physics. In this final chapter, I nonetheless allow myself to take a very brief look at what is on the edge of known physics. If we push the limits of physics, we get to warp drives and wormholes. A warp drive can be seen as a solution in general relativity that allows something to move between 2 points faster than light can. It's theoretically nice, but it requires vast amounts of negative energy density, which doesn't even exist as far as we know. Wormholes are a convenient device in science fiction connecting two distant regions of space, but we have no idea whether they exist or how we could make them, and even if we could, then they seem to be unstable to the passage of a spacecraft. Oh, and they also need large amounts of negative energy. These hurdles don't mean we shouldn't think about exotic solutions or even do more research into them. Just don't count on them to solve your interstellar travel problems in the foreseeable future. In the second part of this chapter, I go back to known physics and summarize what I consider to be the biggest challenges for achieving interstellar travel. These are fast propulsion, communication, and surviving dust impacts. Of all the propulsion methods we looked at, only fusion rockets and laser sails seem plausible, and both of these are far off and require numerous technological breakthroughs. Laser sails will surely be limited to very low mass payloads on the order of grams, so for these, the problem of providing onboard power also becomes critical. Fusion rockets would be much more massive, and the engines can also provide the onboard power. Their already high mass also gives them much more potential to decelerate, using the rockets or maybe by deploying electric or magnetic sails, and to go into orbit around a target star or planet, which is much more desirable than a flyby mission. Communication will probably be done in the optical, whereby arrays of large telescopes on the Earth or in orbit receive the data over a duration of many years. An interstellar mission is a huge undertaking, and we're not going to jump to it in one step. In the chapter, I briefly outlined some ideas for precursor missions to test technology and explore the nearby interstellar medium. Finally, I consider some of the wider aspects of interstellar travel by asking some questions. Should we undertake interstellar travel? Or are there better things we should be doing with our time, ingenuity, and money? Is interstellar travel ethical? What if the target system is inhabited, even with apparently unintelligent life? Is interstellar travel dangerous? Massive lasers built for propulsion can easily be used by malevolent governments on Earth as a weapon against other states. Also, anything moving at 10% the speed of light could be interpreted as a weapon, not least by possibly intelligent life out there. What might aliens make of an entire swarm headed at them? Should we wait? If we optimistically assume that technology just improves of its own accord, then maybe we should forget about interstellar travel for now and just wait until we can build something faster, cheaper, or better in the future. Or would we then just wait forever? And finally, do we need to go so fast? Many of the challenges of interstellar travel come from the desire to get to the nearest star within a human lifetime. But why? Eventually, our ancestors, if we still have any, could reap the benefits of what we do now, just as we reap the benefits of thousands of years of development of civilization. Longer term, multi-generational thinking might have something going for it. And so, this brings us to the end of our journey looking into the physics of interstellar travel. I hope you found it interesting, and I hope you find the book useful too. Interstellar travel is a huge challenge, and there are many technological hurdles that have to be overcome, but it's physically doable. Whether we try to do it, well, that's up to us.